Hello, everyone. Good afternoon. My name is Ragavan Ambighananthan, and I work for Expedia. Today, the topic what we're going to look at is distributed automation using Selenium Grid, AWS, and Autoscaling. End of the day, you travel from different part of the country and part of the world. What are you going to get from this presentation? So distributed automation will phenomenally reduce the UI automation runtime, which in turn will benefit with faster feedback cycle, fewer Jenkins jobs to run automation instead of few hundreds, cost-effective and reliable, and the main important thing is it enables continuous integration and continuous deployment. I have around 40 slides, and each slide is numbered, you know where we are, and I've logically divided the presentation into 5 sections. First, general setup, not the basic setup of Grid, everyone knows how to set it up, but this is the overall big picture, and because the focus is on AWS. And the second section is making the Grid stable. Everyone wants to run Grid, but we want to run it in a more stable way, so it runs today, tomorrow, every week, every month, every year, with very less manual intervention. So what you have to do for that covers that section. I also have another section called Grid Topologies. What are the different ways you can configure the hub and grid nodes to run your test? This is something I learned during the last 1 year when I was doing this as a proof of concept. And the fourth one is cost saving. AWS costs money. And different companies can have different needs. They can spend a different amount of money, so how you can still use AWS and save some money. And also, at the end, it's about reporting and dashboard. So when we move to AWS, what is the problem we are trying to solve? So that is the problem description. We have a UI automation pipeline. We have acceptance and regression stub and acceptance and regression live cases. They run after our CA build runs, and they deploy to a test environment. It takes around 3.5 hours to finish. So that issue, that many hours, it's again, this issue is multiplied by around, on average, 250 check-ins per day. So people check in and they have to wait on the worst case 3.5 hours to see their change, validate a change in a test environment. And the third problem is we rely too much on Jenkins job, and our teams, we have more than 30 teams, and each team owns more than 10 jobs, right? And Jenkins job could fail for various reasons besides failing because of an automation is failing. It could fail because your source control is not working. It could fail because the executor doesn't start a browser on a non-grid environment. And the 30 teams are going to look at their jobs exactly for the same problem, and it's a total waste of time. They might spend like 30 hours looking at the same problem instead of focusing on writing tests and fixing tests. So we want to get away from that and have fewer jobs. The fourth one is not having a system to run vast amount of UI automation reliably, fast, scalable in a cost-effective way. So I think it's a blocker for any company which is planning to do CI/CD. And that screenshot, that's how our pipeline looked like. You can see there are hundreds of jobs, which in turn had lots of downstream jobs, but now we have only like 4. So what is the solution we are suggesting? What is the solution for the problem we discussed? To be able to run all UI automation scenarios within the time taken by the longest test case. If you have 500 test case, I want to run all the 500 test case within 5 minutes. If 5 minutes is my slower test case, right? So I want to run everything executed, finished within 5 minutes. Cost effective, the solution should be cost effective, it should be scalable and reliable. And teams can focus on automation instead of focusing on fixing their Jenkins job and managing their Jenkins job. And we don't need to have like hundreds and hundreds of jobs. Just a note here, this presentation is about how you can run your tests in parallel and not about cross-browser coverage, which you can also use Grid for the same purpose. Just a FYI. So we are starting with the setting up section. So what are the tools and technologies used to achieve this? We have our framework, internal framework. We use Cucumber, WebDriver, and Ruby. WebDriver, most of you know, it's a wrapper over Selenium WebDriver. We use Amazon Web Services. We use Jenkins to run jobs, and Mongo databases. So all the results, all the screenshot, all the HTML reports, JSON report, you name it. And we use Express and Node.js to get the results and show it to teams. So teams need not worry about going to Jenkins and see the results. They can just go to the dashboard, choose a CL, choose their project, see their results. I'm also using 2 different plugins. Both can replace each other. First one is for static setup, which is Selenium plugin, and Selenium Grid Scaler, which is developed by Matthew Hardin, which Marcus just mentioned, which can auto-scale your grid setup. So both can replace each other, which we will talk about later. And also remote parameterized plugin so that I can fully automate my pipeline if I want to run some remote jobs, etc. I can use that. So this is the big picture. This is an abstract picture of how the whole system looks like. So we have a Jenkins node there, which is if you are familiar with AWS, so there are different types of nodes. So that's how the naming convention goes, like C38X large, which is a 32 CPU box. And that is the Jenkins Executor. That is what executes your test. And the way you can see, there are n number of parallel Cucumber tests, and all of them are executed in parallel. And they are pointed to the Selenium hub, which is also a C38X large box, which we'll further look at in detail. And there are n number of nodes connected to the grid hub, and each can run around 24 Firefox instances. And the grid node I'm using is C38X large. After lots of trial and error, I found that C38X large, I can run around 24 Firefox instances at the very same time. And once the automation is finished, all the results are written to Mongo database, and teams can look at the dashboard and see the results. So this is the big picture of the whole setup. And how are we generating the scenarios, right? Grid you can run one test case against multiple browsers, but we are using Grid to run all the cases in parallel, not to cover different browser versions. But how we are running things in parallel. So because we are using Cucumber, it's a BDD tool where you can write your scenarios in any spoken language, like English or French. And every line number the scenario starts, it has certain syntax, like called Gherkin syntax. And Cucumber allows you to run one particular case just by using the line number. So you can say, the feature file .feature : 12, that's the starting line of that particular test case, and Cucumber will just run that scenario. So that's how we are creating, by going through all the projects, and we will create a file with all the scenarios. And if there is scenario outline, the line number would be the line from the example table. So that's another feature of Cucumber. So this is how the generated files will look like. And you can see the feature file has line number, and also the point of sale also associated with the test case, which means we have the flexibility to run. We have around 32 point of sales, and teams can decide, hey, I want to run this scenario against this point of sale, I want to run this against this point of sale, and that flexibility is there. You can tag it, you can use different features of Cucumber to achieve that. And we will run everything in parallel, and how we generate these test cases is we have more tests than what we run, because there are test case tagged as work in progress, unstable, intermittent, you name it, and we exclude all those tests. We run only tests that is tagged predefined tags like stubbed, acceptance, and regression. And these tests will be running in parallel. Setting up, again, Selenium Grid Hub setup, how this is set up in AWS. After lots of trial and error, I found that C38X large, which is a 32 CPU, 60 GB RAM, 10 gigabits bandwidth, is the box to choose for Selenium Hub. And the reason is the node should have high network bandwidth, but low CPU and memory is fine. I will discuss why we need to have a high bandwidth node for Hub later. And for the Hub, for static setup, as I said, we use the Selenium plugin, which you can have a master Jenkins and install this plugin, and the master Jenkins itself will act as Hub, and you can add any number of AWS node as slaves, and that will act as grid nodes. And the plugin will manage your whole Hub and node setup. Instead, you can also use Selenium Grid Scaler, which itself, when it runs, it acts as Hub, but you won't have any nodes. You can tell it, I want n number of, I want to run these many cases. It will automatically spawn the nodes, run your test, and kill it, terminate it. But we will see more detail later. So setting up, how do you set up the grid node? For grid node, as I mentioned previously, we use the node C3X large, which can run 24 Firefox instances. But in terms of Chrome, it's a bit lesser because for every Chrome you run, there's an associated Chrome WebDriver process running. So the load in the box is a bit higher than when you run Firefox. And all grid nodes are attached to the master Jenkins as slave, and that's the static setup of when setting up of node. So just we saw all the setting up, how what node to choose, etc. But now we are moving to I want to have a grid that is stable. It runs every time. It runs in a loop. It runs every day, every week, every month, with very less manual intervention. It shouldn't fail. It shouldn't fail anything. Test case can fail, but the whole system shouldn't fail. So one thing I found out looking at various blog and other places is there are lots of confusion about which one, what timeout, and whether it's milliseconds and seconds. So the biggest takeaway from this slide is when you add this timeout in your configuration, the timeout should be in millisecond, and browser timeout should be in seconds. And the biggest takeaway is the browser timeout should be higher than the timeout and the WebDriver timeout you give, which you use to wait for elements and etc. So if not, you will run into issues. So make sure that this fundamental is there, and you can make sure the right arguments are passed from the Grid Hub console log. Again, timeout. Yesterday, even Kevin wrote this in yesterday's workshop. If a browser instance hangs for any reason whatsoever, it will take 3 hours for the particular slot to become free. You could see that in the grid page, that particular slot is grayed out, even though all the tests are completed, but your job is still waiting, saying, oh, I haven't heard from them. That 3 hour is actually HTTP client socket timeout, and the solution is just see which case is failing it, which case is running into issues, into this kind of issues, and if it's consistent, try to see and fix that particular test. Second, because I want to have a stable setup, what I did was I add a cron job, which will start every 3 minutes and look for any Firefox or browser instances running for more than 10 minutes, and it will just terminate them. There's no reason why a browser should be running for more than 10 minutes for running a UI test, right? It shouldn't take probably more than 2 minutes, 2.5 minutes. And automate it. Any change you make, automate it. So add that as part of your Chef knife plugin. Add it to your AMI, so the next time you don't have to do it manually. So everything is, every small step you automate, and more details you can find about this timeout in pull request 227 in Selenium repo. Another important point, people trying to move to AWS is the grid setup should be in the same subnet. The reason which I found after not using the right way is when you have nodes in different subnet, there's layer 2 level of routing or switching happens, and when you are running huge amount of test cases, there are lots of traffic, and you will end up huge amount of test cases failing with forwarding to node failed error, which is one of the Selenium Grid error. So you need to make sure that when you try to use AWS, whoever you have to set it up, make sure that you have enough, the subnet you are choosing, and the whole nodes and the hub should be always in the same subnet. Everything should be in the same subnet. AWS IP address. The subnet you're using should have enough free IP address. Suppose if you are going with autoscaling instead of static, then you need to make sure that sometimes you might need 40 instances started. Sometimes you might need 60, 80, 100. So the subnet you choose, make sure that you have enough free IP address, because otherwise the Selenium Grid Scaler is going to say, I don't have enough IP address, so I'm not going to create anything, and your pipeline is pretty much broken. And also it will be as I said, blocker for autoscaling the grid nodes. Previously I mentioned that for hub, you need to choose a powerful box which has higher bandwidth. And the main reason is, which again I found when I was doing the proof of concept, when you run around 250 tests in parallel, and if you look at the AWS monitoring console of the hub, you could see the bandwidth goes up to around 6 gigabits per second. And I thought it's because I'm running too much tests, but actually it's happening when you create the WebDriver. And yesterday I confirmed that it's very plausible. It is the behavior that you're seeing. And yeah, it's because when you create the WebDriver, you're passing all the information and the config and everything. So imagine if you're running 500 tests, then you pretty much you will use all the 10 gigabit bandwidth of C38X large. That's one of the powerful boxes in AWS. So again, depends on your taste, depends on your test and your company and your how many tests you have. Make sure that whatever box you use, monitor what kind of bandwidth and what kind of CPU and what kind of memory is necessary, and then use accordingly. Another important thing you need to make sure for making the grid stable is your Java settings, the XMS and XMX, and also dpool max. If you use more nodes, make sure that you use that. You can pass that to the Jenkins in the static setup, or you can pass that as a command line argument in the for the Selenium Grid Scaler plugin. Again, this is another important thing. I'm running around 5,000 UI tests, right? And sometimes I see the hub becomes unreachable after I run 2,500 case. And what I did was I automate restarting the hub as using the remote plugin. So after I run 2,500, I will restart the hub and then start the rest of the test. This way, this is another way for me to automate a reliable system. I don't want anything failure, and if it fails, what is the solution? And this is another important thing when you choose to move to AWS is the Jenkins Executor that you use, it needs to be powerful. It needs to have powerful CPU. Like this one, for example, is C38X large. It has 32 CPU. When I run 250 cases, that's what you see. All the 32 CPU are at 100%. So in that box, that's how much you can run in parallel at the very same time. So if you want to run more, so it's not the hard-coded number 250. It could be plus or minus 50 for your setup, but there is a limit that you can run at the very same time. It depends on your test, your framework, but probably it's 300 or 200. But there is a limit you can run at the same time. Making the grid stable, another point here is everyone knows that Grid Hub has a queuing policy. You can rely on it to some extent, but don't rely on it too much, because if your average test execution time is greater than the WebDriver timeout, your test will time out at the web creation itself. So you can probably, if you have 100 tests, you can if you have 100 slots, you can probably run 115. That's fine, but not like 150, right? So that's important thing you do. Again, this is another important thing. You might have the greatest grid setup in the world, but it's totally useless if you don't have your test infrastructure scaled. As soon as you make a grid, make sure that you have more nodes behind your test servers. Also, if necessary, if there are services it's talking to. Otherwise, doesn't matter how good your grid setup is, it's pretty much useless. because tests will fail. Okay, now we just saw about all the how you can make your grid setup stable, all the important things, and now I'm going to talk about grid topologies. So before deciding what topology to use, I want everyone to think about these questions and answer them so that you can decide what you want, right? You can decide what you want, how much you're going to spend, or how much you can spend. I want to release code to production. I want to release every CL. There are companies doing that. I want to release once a day. I want to release once a week. Or I want to release whenever I want. I don't want to release, but I want to be ready whenever I want to release, right? Based on the answers of those questions, then you can answer the second set of questions. How often I want to run automation if my answer is X from the first set of questions? Every CL, you want to run every automation against every CL, or every 2 hours, or every 4 times a day, but not once a week. Regardless of that, don't run once a week. You have to run more than that. So based on that answer, you can pretty much decide there is a cost, then there's only so much faster you can run, right? So this is one grid topology. It's a very simple setup for small companies, small test cases. Jenkins Executor, C38X large, hub, and there are like 11 nodes. I can run 250 plus 260, 75 cases in parallel within 5 minutes. So I can just finish all the tests and done with it within 5 minutes. Grid topology 2, if I have say 550 cases, I can use another executor in parallel and run 500 test cases in parallel using double the set of nodes, C38X large nodes, and all of them are Linux, by the way. And I can still run everything in 5 minutes. But 2 executors, 1 hub, and 22 nodes. Grid topology 3, instead of the previous topology, you can actually run those 2 jobs in sequence instead of parallel. The result is your test is going to take 10 minutes compared to the previous topology 5 minutes, but half the cost, right? Because you are using only 1 executor instead of 2. You're reusing for the next job, and you're using 1 hub and 11 nodes instead of 22 nodes. So even though your goal is to run every test case within the time taken by the longest test case, there are ways you can save cost. I'm not saying you can't run, it's possible, as we have proven it, but there is cost involved, and that's the whole point of the presentation. And you have more tests. Say you have 1,000 or 750 or some test. Then if you ask, like, can I add 1 more executor? Remember I talked about bandwidth. If you try to run 750 cases in parallel, your hub is not going to handle that bandwidth at the same time. You can run, probably you can add a slight delay when the test starts, like probably 5 minutes starts. But this is just an FYI. Make sure that you know what will happen. Monitor your dashboards and make sure that whatever hub you choose, you have to decide when to stop scaling. But what I would do is, this is group topology 4, use 2 hubs to double the test to 1,000. Speed is same as topology 2, 5 minutes, but cost is double. You can use 4 executors, 2 hubs, and 44 set of nodes. So we just saw a set of topologies, how different topology you can run. I'm not saying that's the only way, but there are so much other ways. But I don't have time for, I only have like 45 minutes. And now cost saving. So one other point is optimal use of grid nodes. Second, stopping nodes when not in use, or autoscale Jenkins executors, or autoscaling of grid nodes, and reducing UI tests. That's, I think, one of the important thing which even Anand was talking about right at the moment in the next, in the other presentation. So optimal use of grid nodes, running 250 tests on a grid setup with 250 slots will take 5 minutes. But if you know, AWS bills you for an hour. If you use, whether you use for 1 minute or 60 minutes, it's the same price. So you're paying for 1 hour, but you're only using for 5 minutes, right? We have to change our thinking, like, because we are using, normally every company use a data center, they have VMs, so we don't think about the cost, but here it's being paid for per hour, right? So you have to change the way you think about the money here, and so here you are actually not using 55 minutes worth of time, but you are actually paying it. Even during the 5 minutes of the run, very minority of the test case takes around 5 minutes to finish. This is from my observation. It could be a different percentage. But majority of them finishes within 1 minute. And during those 4 minutes, those slots are just idling. You're not making use of it, which means you are actually throwing money, but you're not using it correctly. This is just a pictorial representation of what I said. As you can see, the way grid nodes are run is on a round-robin fashion, and you can see there are not grayed out slot. That means they are run and they are just waiting for the whole thing to finish. So this is what I call batch processing as a solution to this problem of not using the grid AWS optimally. So on a C3-8X large, 250 cases can be run at one go before all 32 CPU reach 100%. So what I do is I start 250 cases, wait for 50 seconds. That's a number that you can fine-tune based on observation, and run 100 tests and wait for another 30 seconds or 50 seconds and run, and keep on until you finish all your tests. This way, if you can fine-tune, you will always make use of all your nodes and slots the most optimal way, and you will get everything what you are paying for. And fine-tune the delay according to your observation in your infrastructure and testing. So this is the batch processing topology looks like. So I have 2 jobs, one for acceptance stub and regression stub. These jobs run sequentially. I only use 1 executor, 1 hub, 13 nodes, and I can run 5,500 U automation within 1 hour and 40 minutes. And it can scale. I can keep on adding. Of course, the time will keep increasing. But this way, if a different company wants to save money and they decide, they answer the questions correctly, which I showed you previously, then if this is okay, then this is perfectly fine with you, right? Or if you choose, you can run everything in parallel. It's up to you, up to different companies. Comparing AWS cost to data centers, this is the number I got from my company by some calculation. One medium box in your in our data center costs around $8,000 per month. This is excluding the price of the box. This is, you pay for people to manage the boxes in the data center and etc. And when you divide, this is how much it costs per box per month. For one large box, it costs around $10,000 per month. For one VM, it costs $2,000 per month. For the previous topology that you saw for batch processing, it costs around $800 per month for the whole setup. So it does save you cost, it does save you money, it does allows you to scale. So you have to decide, so this needs some paradigm shift, how you think about how much you are spending. You can also, in the static setup, you can also stop the nodes when not in use. In Expedia, we run our test after every deployment we run, and the next deployment happens, it goes on a loop. So it's run, we execute around like 9 times a day. But if people want to run like 4 times a day, then the rest of the time you can stop it, and AWS charges you only for the EBS volume you use, which is very few cents a month. But only disadvantage is if you are using a huge amount of static nodes, you're actually holding those IP addresses, and which might be necessary for your company if it is a problem. Autoscaling of grid nodes. That is the Selenium Grid Scaler that I am using. It creates AWS nodes on demand based on a configuration file where you specify what AMI to use, and what security role to use, and what subnet to use, and etc. And you also pass the number of tests to run. This acts as a hub, and you also have a pre-configured AMI that will act as node. That AMI ID, you give it to the hub, and whenever you want to create, it will actually create. This is how it does it. So before every Jenkins job, you request this URL and say, hey, I want to run this many number of tests. And you won't have any nodes before that. And what it does, it divides that number by 24, which is the maximum number of Firefox you can run on a node. And it will say, hey, okay, you need 12 nodes to run this test, and it will check if it already has a capacity. Then it will return one type of code is 202, which means that, hey, I can run your test. So I don't have to wait. I can straight away go and run my test. If it returns 201, which means I can fulfill it, but I need to create a new AMI to meet your capacity. So I know that 201, then I'll wait for like 7 minutes and then start my test. And after 55 minutes, it'll wait, it'll check, are there any more tests running? And if there are no tests, then it will terminate it. Because instead of killing it immediately, anyway, AWS is billing us on an hourly basis, so you wait until the 55th minute and check, like, are we still running tests? So you kill it at the right time. And the next one, it'll create new nodes. Reducing UI test is one of the important aspects that we are looking in at the moment. Monitor UI test trend with strict review process. It's easy to get into thousands of UI cases. The thing is, you have to see, is it adding value to your company? Is it adding, when you are checking a pop-up, how many people are actually using it? And so keep reviewing, keep a continuous review process. Whenever new test cases are added, ask question, do we need it? Do we need this? Can we push this as an integration or unit test so that you don't end up with thousands of UI test cases? And categorize only release blocker test as acceptance. You might see there are lots of acceptance cases are failing, which means are we going to stop release? If not, then why the acceptance, right? So you need to make sure that you categorize test and you take decision based on that. If a test fails, then are we going to stop the release because this test case is failing? Or can we move this as a regression where we still can release, but we can fix it later? So this way, you are making it as a best practice so that you don't end up with large amount of test case probably after 6 months. Each test should focus only on one use case. So you have faster running tests instead of tests running for 10 minutes, and break down bigger scenarios to smaller ones. This is the abstract pipeline we have in Expedia. This is very abstract. There are lots of things in the middle. So I just want to show that we have a CA build. We run all the tests, unit integration, smoke tests, and once it is done, it promotes and deploy the build to a stub box. We also have an unstub box, and it kickstart the master job, which will start the nodes, run acceptance, restart hub, and run regression stub and stop the node. Also, it's same for the Selenium Grid scaler, where the nodes are, created on demand, and that's the setup. So this is how the pipeline looks like, and it takes 2 hours, around 2 hours, including the start time, stop time, and all those things. If you want to release 1 hour, you can, split the job into 2, and pretty much you can finish this in 1 hour. So one thing when we got rid of Jenkins job is because jobs got purged and you don't have history of what happened, right? Sometimes. Now what we're doing is we are storing everything: screenshot, HTML report, JSON report, all the statistics, pass, fail, everything, errors into Mongo database after every job. And we have a Node.js Express-based dashboard. So teams can go and choose a latest deployed CL and their project and type of test and actually see what kind of failures they have. They can see the screenshot, HTML report. And because we have lots of data and there are so many different ways you can present it. We have a history, like for example, if a test case failed, you can see the history of that failure across n number of builds and see if there's a pattern, right? And we have a dashboard for that. also, we have an RSS feed for every project, so they can subscribe to, and that will push them, whenever their test results are ready, that will push them, and they can actually see a failed screenshot, they can see the HTML report, they can see the Splunk query for that particular failed page, they can see the CL number and when the test ran and the project. So what more we need to debug a test, right? So you have everything right at your doorstep to fix when things fail. So that is the end of the presentation. So if you have any questions, thank you. Yep.
For your nodes agents, what are you using for operating system?
Linux. Everything is running on Linux. All the executors, hub, and nodes. Yep. Yes, we do use XPFP. Yeah. So XPFP is the which adds the head to the operating system so that you can run browsers. So yeah. Yes. We did try, but for the amount of test cases we have, it'll be pretty expensive because, say, if we have around 5,000 test cases and we want to run faster, so that's, I think, if I run in AWS, and we are not looking at browser coverage, so that's what Source Lab is for. We are looking at, we want to run everything at least on one browser, right? So for this, I think Source Lab, AWS works for us. Yep.
So I'm curious about your batch processing of the job. Like, is there a job by itself or a service which you're calling out?
So we use Rake for that. So imagine like a loop. I'm creating a process for every test case. There's a delay of 200 milliseconds so that I don't hit the server. And there I have a logic where I say, every 250 or, so this is something you can fine tune. So I'm doing at the Rake level, at the Rake task level.
Where are you on this loop? So is this a loop with the Jenkins job or is it some kind of?
This is as part of the framework. So we have a Rake task that runs all the test cases in parallel. So the logic is right there. Yep.
Have you run into any issues with running so many concurrent Firefox instances?
We ran into that issue before, even before we moved to AWS, and there is a profile variable that you can fix. I think it's called test mode or something. So we managed to fix that, and we always make sure that we use .focus so that we don't have those issues. Yeah. Any questions? Any other questions? Pardon? I'll make it available somewhere, SlideShare or something, yeah. Yeah.
So my question was, in your, I think you called it CI stub, is that where the application is being tested?
Yes, so we have a test environment, so a CI stubbed and CI unstubbed, or we can call trunk stub and trunk unstubbed. And we deploy our product, our website to that, and it has 8 nodes behind it to scale, and we test against that. Yep. They are running on Linux, but not yet on AWS, but that's a plan, yes.
So when you put the results in the models, do you have to run them like control yourself, or do you have some kind of tools or open source to pull the results?
For showing the results from Mongo?
Yeah.
So for that, we have the Node.js, right? So Node.js can pull data from Mongo and Express.
So it's your application or it's some kind of?
It is what we developed from scratch, yeah. It's just basically Node.js and Express, yeah. Any other questions? Otherwise, yeah, good. Thank you very much.